Let's take a look at the three most common problem types that occur with quadratic modeling, and then the tools we can use to answer those. So the three most common types are going to be ones involving a rocket, profit and revenue, or area. Today we're going to tackle the rocket, profit, and revenue type problems. There's going to be three key features we're focused on today: the vertex, the zeros or x-intercepts, and the y-intercepts. And we're also going to look at the different tools that can be used to tackle each of these problems. Let's look at our first example. A company sells hot chips. The amount of profit, f of x, made by the company is related to the selling price of each hot chip, x, by the given equation. Using this equation, find the maximum amount of profit the company can make to the nearest dollar. So let's start by defining our variables. Our x is the selling price. I know this because it told me in the problem. And our y, our f of x, is the profit. Since it's asking for maximum amount of profit, I know I'm looking for my y. My end goal is the y value. I'm looking for my maximum, which means I'm looking for my vertex. I'm going to show you today how we can use both of these tools to find that vertex. You can choose which tool you want to use. Let's start with the first one. We're going to use our axis of symmetry formula. That's x equals -1 times b over 2a. This is an option for you. You just pull out your a value and your b and plug them into the equation. Put that in the calculator and you'll get 31.72. That's not my final answer though, because I'm looking, remember our goal was y, our goal was maximum profit. What I'm looking at here is my selling price. So if I have if x is my selling price, then I know that 31.72 is a selling price. That'll get me my max profit. So let's go ahead and plug this number back into our original equation. So anywhere we see an x, instead we're going to write our selling price. We put all that in the calculator and we see that our y, our profit, is $5,172.69. That is our final answer. Now we can also use a graph to solve this problem. Go to desmos.com and type in the function. You might need to zoom out using the buttons you see on the right-hand side until you can see your whole graph. All right, now I can kind of see the whole thing, but it looks weird, so I'm going to go to my settings. I'm going to change the x's to say -10 to 100. Just some easy numbers to kind of widen everything out. Now remember, we're looking for the max, so we're going to click on our function. We're going to look at the maximum. We're looking for maximum profits. That's our y value. So you can see our answer is $5,172.69. Exactly what we got when we solved it by hand. Now let's look at problem 2. The path of a rocket can be modeled by the equation below. At what time does the rocket hit the ground? So first I'm going to define my variables. X is most likely going to be time, and my y, my output, represented by g of x, is going to be height. At what time does the rocket hit the ground? Okay, that would be a height of 0. So let me set my equation equal to 0 because my y is the variable that represents 0. So it looks like I'm looking for a 0 or an x-intercept, and we're going to solve it two ways. We're going to solve it by factoring and graph. I'm not going to use the quadratic formula because there's no c value, so I think these other two options would be easier. Let's try factoring. I'm going to pull out a negative 16x, and when I do that, I'm left with x minus 7. Negative 16 times a negative 7 is 112. Now set each of my factors equal to 0, and I'm going to solve for x. So I see over here that at 0 seconds I'm on the ground. Okay, that one represents the beginning. And I see over here that at 7 seconds, my rocket's back on the ground. So that's probably the answer they're looking for. 7 seconds. This problem could have also been solved by graphing. Go type your equation into Desmos, and then zoom out until you can see all of it. And if you need to, change your x's. You can even zoom in more if you need to. We're looking for x when y is 0, so I'm looking right here at this axis. And I see there's two places where y is 0, at x equals 0 and at x equals 7. So at 7 seconds, my rocket hits the ground, the exact answer we got when we did it by hand. In summary, there are multiple tools that you can choose from to find your different key features. It's up to you to pick which tool best suits the situation you're looking at.